Ever wondered, as you gaze at the stars, how long it would really take for a spaceship to withdraw from, say, a deep space mission? We often see dramatic, instantaneous departures in movies, a quick flash and they're gone. But the reality is far more complex, a carefully choreographed dance of physics, engineering, and human ingenuity. It's not just about hitting the gas, it's about shedding the incredible inertia of space travel, navigating celestial mechanics, and ensuring the safety of everyone on board. Think about it, a spacecraft, especially one that has been on a long journey to Mars or even beyond, isn't just hovering in place. It's likely orbiting a planet, or even the sun, at incredible speeds. To withdraw isn't merely to turn around and head back. It's to alter an established trajectory, to overcome the immense gravitational pull of a celestial body, and to precisely calculate a new course that will lead it safely home. This process is anything but instantaneous. The duration of a spaceship withdrawal, therefore, isn't a single, fixed number. It depends on a multitude of factors, each playing a crucial role in the overall timeline. Let's break down the key considerations. First, the location of the withdrawal is paramount. Withdrawing from low Earth orbit, LEO, is a vastly different proposition than withdrawing from Martian orbit or, even more challenging, from an asteroid belt hundreds of millions of kilometers away. The further you are from Earth, the more significant the gravitational forces you need to contend with, and the longer the journey home will be. For instance, withdrawing from LEO might involve a relatively quick deorbit burn and atmospheric re-entry, potentially taking hours or a day at most. But a withdrawal from Mars orbit could take months, factoring in the planetary alignment for the return journey. Second, the type of propulsion system on board significantly impacts withdrawal time. Chemical rockets, while powerful for initial thrust, are less efficient for sustained, long-duration thrust changes needed for significant trajectory alterations in deep space. Newer technologies like ion propulsion, while providing continuous low thrust over extended periods, might take far longer to achieve the necessary velocity changes for a quick withdrawal, even if they're more fuel efficient. Nuclear thermal propulsion, a technology still in development, promises to bridge this gap, offering both power and efficiency, potentially shortening withdrawal times for future missions. Third, the mass and size of the spacecraft are critical factors. A smaller, lighter probe can alter its trajectory much more quickly than a massive, fully crewed interplanetary vessel. More mass means more inertia to overcome, requiring longer and more powerful engine burns. Imagine trying to stop a bicycle versus stopping a fully loaded freight train. The principle is similar. Fourth, and often overlooked, are the orbital mechanics and planetary alignments. Space travel isn't about straight lines. It's about gracefully navigating gravitational wells and slingshotting around planets to gain speed. To withdraw from a distant location and return to Earth efficiently, mission planners must wait for optimal planetary alignments. These launch windows or return windows only occur periodically, sometimes every couple of years. Missing one could add years to the withdrawal timeline. This waiting period is a significant, often unhighlighted, component of the overall duration. Finally, there's the human element and mission objectives. Is it an emergency withdrawal, requiring rapid, though still carefully planned, maneuvers? Or is it a planned return at the end of a successful mission, allowing for a more leisurely and fuel-efficient trajectory? The urgency of the situation can influence the risk tolerance and, consequently, the speed of the withdrawal. So, when we consider the question how long does a spaceship withdrawal take, the answer is a complex tapestry woven from location, propulsion, mass, celestial mechanics, and mission parameters. It's a testament to the incredible precision and foresight required for space exploration, a process that can range from a matter of hours to several years. It's not a quick cut in a movie, it's a profound journey in itself. With that said, thanks for watching and until next time.